Now we are going to discuss the equation of stoichiometry. So the first part is to write the balanced equation. We have learned how to balance the equation. So if we are going to talk about the combustion of methane, right? So combustion of methane means CH4 plus O2, that will give CO2 plus 2H2, right? This is the balanced equation. Now here it is clearly written that it is one molecule of CH4, or I can say that if I have taken 16 gram of 16 gram of methane. If I have taken 16 gram of methane, then what is the number of molecules of methane? Simply we have to divide 16 gram, that is 18 gram, by molecular mass. So here carbon is 12. If I'm going to calculate this molecular mass, and hydrogen is 4, right? 4 hydrogen, 4. One hydrogen molecule mass is 1, and carbon is 12. It is 16. So 16 over 16, it will come 1. So it is now clear that one mole of methane will produce 2 mole of H2O, as I have written, that is CH4 plus O2, that is CO2 plus 2H2O, right? So if I have taken one mole of methane, then it will produce 2 mole of H2O, because in the balanced equation it is clearly written. So if I have taken 16 gram of methane, what does it mean? It means 1 mole of methane. I have I have used the formula of number of moles to determine what is the number of how many moles are there in 16 gram of methane. It is 1. So if it is 1 mole of methane, if we have taken, and we have 1 mole of methane, it will produce 2 mole of water and 1 mole of carbon dioxide. This we will determine from the balanced equation, right? On that basis we are going to calculate, we are going to solve some questions. So here it is, the lines are written, that is 1 mole of CH4 reacts with 2 moles of O2 and produce 1 mole of CO2 and 2 moles of CO2, right? In terms of molecule, if we talk about, then again 1 molecule of methane will produce 2 molecule will react with 2 molecule of O2 and to give 1 molecule of CO2 and 2 molecule of H2O in terms of molecule, right? If we talk about, if we have taken the gaseous, all the reactants are gaseous, or we have taken in liter, right? So 22.7 liter, that is the 22.7 liter of methane we have taken. So it will react with 44.4 liter of O2 and will give 22.7 liter of CO2 and 44.4 liter of H2O. So just multiply it by 2, you will get 44.4 liter. So 1 mole of ideal gas at STP contains 22.7 liter, right? So if it is asked that how much volume will gas occupied, and ideal gas will occupied at yeah, if somebody asks you that how much volume will an ideal gas will occupy at STP, that is standard temperature and pressure, then your answer will be 22.7 liter. So at STP an ideal gas will occupy 22.7 liter. So again, if we have taken ideal gas, that is CH4, right, its ideal concentration, then at STP it is 22.7 liter. 1 mole, it is 22.7 liter. 1 mole of an ideal gas occupied 22.7 liter. So 1 mole, what will occupied, how many liters? That is 22.7 liter. So if 22.7 liter of methane is taken at STP, then it will produce how many liter of water? So simply you know that in a balanced chemical equation, 1 mole of methane will produce 2 mole of water. So 22.7 liter, that is 1 mole will equal to 22.7 liter. So 2 mole will equal to into 2, that is 14.5 44.4 liter, right? Again, in terms of, if we take in gram, so 16 gram of methane, methane reacts with 32 into 2 gram of O2 and will produce 2 into 18 gram of H2O. Again, in terms of gram, if we talk that H2O molar mass will be 18, and if we have taken 6 CH4, that is 16 gram, right? If you have taken 16 gram, it will produce how much? That is 2. From a stoichiometric equation, from a balanced chemical equation, we know that it will produce 2 molecule of H2O. It means if we have taken 16 gram, then it will produce how much? Suppose in a balanced chemical equation, you know that one simple molecule of CH4 will produce 2 molecule of CH4, that is H2O. And if we take 16 gram of methane, then automatically H2O molar mass is 18, and we know that from a balanced chemical equation, H2O is multiplied by 2, it having a coefficient of 2. So we are going to multiply 18 into 2, that is become 36, यानी कि 36 gram, right? So now on that basis, we on that concept, we are going to calculate question. Calculate the amount of water produced by combustion of 16 gram of methane. I think we don't need to solve this equation. Already we have discussed these equations. Suppose again the question is very simple. It is asking you that if 16 gram of methane is taken, how much water will be produced, right? So first we are going to write a balanced chemical equation. It is written here, right? So we know that the molecular mass of CH4. So first we are going to calculate the molecular mass of CH4, that is carbon 12 plus hydrogen 4 into 1, it will become 16. So now our second step is to calculate the number of moles. If we calculate the number of moles, so for that number of moles, we write weight in gram by molecular mass. For methane, it will weight in gram is 16 gram. It is given in the question. Molecular mass 16. We have just calculated. It will become 1. Now, we have one mole of methane, right? So 1 mole of methane. From a balanced chemical equation, it is clearly shown that if 1 mole of methane is burnt, it will produce 2 mole of H2O, right? So if you have taken 1 mole of methane, it will produce how many moles of H2O? It is 2 H2O. That is 2 moles of H2O. So 2 moles of H2O will be produced. Now if we are going to calculate the mass of H2O, so again I am going to write the formula of number of moles. So we know that how many moles of water will produce, that is 2. So according to the formula, weight in gram by molar mass, right? So H2O molar mass, what will be the molar mass of H2O? Oxygen 16 plus hydrogen 1, and there are 2, so 2 into 1, it will become 18, right? So we are going to put 18 in molar mass in place of molar mass. So the equation becomes 2 is equal to weight in gram by molar mass is 18, right? So weight in gram, what will become the weight in gram? So just weight in gram will be equal to 2 into 18, that is 36 gram, right? So it is a simple calculation. You can calculate it by yourself. So there is another question. I hope you can solve this question by yourself. Now we are going to talk about limiting reagents. So what is the meaning of limiting reagents? Again, the term limit, you know what is limit. If you put limit on something, suppose you have